Hey there, welcome to another session of math problem solving. This is Bharat Divyang from the Zone Academy. So I hope you watched last week's video, which was about how one can figure out the number of factors for any given number. So just to quickly recall, every single number can be broken down into its prime factors, P1, P2, P3, let's say. And usually they have some kind of an exponent like E1, E2, E3. Then the number of factors is given as the product of 1 plus E1 times 1 plus E2 times 1 plus E3. So this is what we looked at last time. So if you can prime factorize any given number, you will be able to find all the constituent prime factors and the exponents of those prime factors. And if you can pay attention to those exponents, you will be able to figure out the number of factors. And the video was about the proof. If you haven't watched it, please do go check it out. But today, we're going to go one step further and look at the application of this. Find the largest two-digit number with the most number of factors. So we know the numbers are going to be between 10 and 99. One of these numbers is going to have a lot of factors compared to the other. Now, the brute force method, of course, is to literally start from 10, go all the way to 99, list down every single number, figure out what is the number of factors there is, and for 90 such numbers, you get the answer and eventually arrive at the list of numbers which have the highest number of factors. This is brute force. It can be done, nothing wrong with it. Most computers would probably write a program which would essentially work on this. But what we want to do is to find a smarter way to do this. And to that, we're going to apply what we learned last week. So if I take any number, for example, a prime number like 97, then we know that it has only two factors, 1 and 97. So all prime numbers have two factors. So prime numbers typically don't work out. We could think about the largest number, which is 99, and we know that it's 1 and 99, 3 times 33, or 9 times 11, making it 6 factors. So can there be something better than that? Let's try 98. And 98 would be 1 times 98, 2 times 49. You already know it's a factor of 7. None of the others, not even 4, not even 6. So let's do 7 times 14, and that's about it. Again, there are. So the top three numbers are giving you some answer, but how can you be 100% sure that one of this is the answer? Can this be done in a different way? Yes, every single number is going to have prime factors. And those prime factors is going to be a single prime factor, which means there's only P1, or it could be P1, P2, or it could be a value of three factors, P1, P2, and P3. Okay, now let's take the case of P1. So the smallest prime factor is 2. 2 raised to the power, because this is an example of a number which has only a single prime factor. Now we know 2 to the power 4 is 16, to the power 5 is 32, to the power 6 is 64. To the power 7 is 128, becomes too large. So in this case, 2 to the power 6 is 64. And the number of factors is nothing but 6 plus 1, which is 7. So you already see that it's better than 99 and 98. So 64 is your current answer in hold, unless a number can be made better than this. Is it possible to have another prime factor but still a single prime factor, for example 3? The answer is no. 3 to the power 4 is 81, definitely larger than 64, but the number of factors here is only 5. It fails. 64 has more factors than 81. What about 5, you may ask? 5 is also 5 square. I mean, you can't even go beyond that, right? Like 5 square. Because 5 cube is 125, which means the number of factors is only 3. Right, so this doesn't work either. Same thing with 7 squared, which is 49. That's about it. So a single factor doesn't work. What about two factors? So one of the ways you can do it is, 2 to the power 6 is 64. You also have the intuition that lesser the factor, greater the power, and power has to be higher. So in this case, you could think of it as 2 to the power 5 times 3 as a possible option. Times 3 as a possible option. 2 to the power 4 times 3 square as a possible option. So let's think of the first one now. So 32 times 3 is 96, pretty big in itself. And the number of factors for 96 is going to be 5 plus 1 times 1 plus 1, giving you 6 times 2, which is 12. This seems to be definitely higher than 64. So our new answer and hold is 96. And you know what? You could end the game here, because 97, 98, and 99 all have lesser factors than this. So 96 is the one which highest number of factors possible. But you can't really end it here, because it is quite possible that there might be a number which has more factors than 12 itself. So we need to eliminate that. That's the reason you can't end this. Right now, 96 is our answer and hold which has 12 factors. So the only way somebody can beat this is if they have more number of factors than 12. So if they have more number of factors than 12, then that number of factor can be 13, 14, 15, or 16. So for 13 to be there, the only way it's possible is, because 13 is a prime number, the power has to be 12. And this is not possible when you're dealing only with 2-digit numbers. And this can work out only if it is 2 times 7. So a single factor with a power of 1 and the other factor has a power of 6. Again, this doesn't work. This can happen only if there's going to be 3 times 5. So something with square and something with 4. For example, this one. So let's test this out. 2 to the power 4 is 16. And 16 times 9, unfortunately, is much, much greater than 100, and therefore 15. This number would have definitely been a higher number of factors, but doesn't work out. So this, about 16 factors is possible if it is either 4 times 4 or 2 times 2, which is 4, times 2, which is 2. Okay. So is it possible to have all 4 separate factors? Let's test that out. So 2 times 3 times 5 times 7. So that's 6 times 5, 30, 30 times 10, 210, and that's when you have 16 factors. Can this be reduced in any which way? So you can have 2 times 2 times 2 times 4, which one of them has to be cubed, that has to be 2 cubed. 8 times 3 times 5 times 7. If 2 times 3 times 5 times 7 doesn't work out, this definitely is not going to work out either. So given that none of this seems to work, a fair enough approximation here would be that 96 is probably the answer. So 96 is the largest 2-digit number with the most number of factors, which is 12. Anybody beating that is going to be highly improbable. What would be the next number right after that? Maybe you can think of it as maybe a 3-factor idea, where you have 2 to the power 3. So 2 cubed, which is 8, times 3 square, which is 9, which is 72. And this would basically be 4 times 3, which is 12. So 72 definitely works out. Instead of 72, you could replace 3 with 5, which means you have 8, or 8 times 3 times 5, which is too big. So which means replace 2 here. So instead of 8, you have 4. 4 times 9 times 5 doesn't work out. So 2 times 9 times 5 might work out. Yeah, 90. So which is nothing but 2 to the power 1. 3 square, 5 to the power 1 is going to have 2 times 3 times 2, which is going to be 12. So right beneath 96 is 90, but 90 is smaller than 96, and therefore 96 is the answer. And if to the question of find the largest 2-digit number with the most number of factors, the answer is 96, which has 12 factors. I hope you found this video interesting and the solution something you could follow. I know it's slightly complicated, but and it requires a bit of intuition, and it's not completely procedural. But if you do follow it, watch the video. I mean, if you find it hard to follow, watch the video a couple of times, and you should be able to get it. If not, please leave a quick comment. I'll be happy to address that. Thank you so much. Please do like, share, and subscribe without fail. Looking forward to seeing you next week.